Okay, for this little video, a little extra help for you, we're going to calculate B to this question. So a reminder, the question says a ball is thrown upwards near the edge of a 300-meter high building, initial velocity of 20 meters per second, no air resistance, make things a little bit easier. In part A, we calculated the time to be 2.0 seconds, and in B, we're going to calculate the maximum height of the ball above the ground. So what we're measuring that maximum height relative to is very important. It's not how high above the building, it's how high above the ground. So I'm going to write out all of the variables I know. I know that my initial displacement is 300 meters above the ground. I know that my initial velocity is 20 meters per second. That's upwards. My acceleration is negative 9.81 because it's on Earth, meters per second squared. My final velocity, because it's at maximum height, is going to be 0 meters per second. Now you might be tempted to write down the time of being 2.0 seconds here. I'm not going to do that just because what if it's wrong? It's something we calculated in part A, and if I made a mistake with that and I use that value in this setup, the solution for maximum height above the ground will also be incorrect. So with that in mind, this is the equation that I will use. So it's final velocity squared equals initial velocity squared plus 2 times the acceleration multiplied by the displacement. All of those variables contain what we're trying to solve for and what we're given in the problem. So none of those variables had to be calculated. So the safest bet is to use this equation. Rather than taking a chance, we made a mistake solving for time. Now one thing we have to be very careful with now is that displacement is your final position subtract your initial position. We're not starting on the ground. We're starting with an initial position of 300. So our df is going to measure where we are above the ground. So I'm going to read the equation just one more time. Vf squared equals v initial squared plus 2, our acceleration, and then I'm going to put in here final position minus your initial position. And we're ready to go. Okay, so put my values in. Final velocity is 0. Initial velocity is 20 squared plus 2 times negative 9.81. And then my final position, that's what I'm going to solve for. That's going to be my maximum height. It's my maximum height when my final velocity has reached 0. And I'm starting with an initial height of 300. So you just have to be very careful with the math here. So just working with that right side, simplify it a little bit. 20 squared is 400. 2 times 9.81 will be negative 19.62. And I didn't do anything with the brackets yet. Now be careful with the math here. That negative 19.62 has to multiply both terms inside of those brackets. Forgetting one, and your question is wrong. You've done the wrong math. So 0 equals 400 minus 19.62 df, or maximum height in this question, plus 300 times 19.62, which is 5886, so thereabouts. So notice it turned into a positive as it's a negative multiplied by a negative. Simplifying a little bit and bringing numbers to the left side of the equation, negative 6286. So that number comes from doing 5886 plus 400 equals negative 19.62 df. Dividing both sides by that negative 19.62 gives us 320 meters as our maximum height. That makes sense. Okay, going back up to the top, we're originally 300 meters high, so we had an answer above 300. So this thing goes about 20 meters above the building.